All right, guys, so we're going to talk quickly about volumes of cones, cylinders, and spheres. So we have already talked about how that the sphere is 2/3 pi r squared h, the cone is 1/3 pi r squared h, and the cylinder is pi r squared h. So here you have a picture of the shapes here. So this one is the cylinder in the middle here. And remember that it is the base shape which we use, that the volume of this one is pi r squared h. And from the water experiment that we did where we saw that 3 cones of the same height as the cylinder would make a cylinder, we know that the volume of the cone is the same as the cylinder except for it's 1/3 of it. So we put the 1/3 pi r squared h. Now one other way that you could write this is because you're dividing by 3 is pi r squared h all over 3. Either one of those is fine. So then the sphere, we know that it is 2/3 the volume of a cylinder. So we can just put the 2/3 in front of it. And you might see it written like this, 2 pi r squared h all over 3. Either one of those is a sufficient way to write that. But notice in all 3 of these formulas that you have r, which is the radius. Now remember that r is from the middle of the circle out. So this one, the radius would be here. This is the radius here. And this is the radius here. Okay, this would be your height of your cone, your height of your cylinder. And now if we notice here that the sphere, which has a ball shape, it does not have a height per se. But we know that in a cylinder, the diameter is actually the height. So you would use the whole side for h. Okay, so this would be the diameter. Okay, diameter. So basically, in any volume question that you get, you have to determine which one of these formulas that you want to use. Now we also know that there's another formula for the sphere that you may see, which is volume equals 4/3 pi r cubed. Now the reason this formula works is because the diameter is twice the radius, which that means the height is twice the radius. If we take our formula and say that 2/3 pi r squared, and instead of height we put twice the radius and put that all together, we see that that becomes 4/3, because 2 times 2 is 4, pi, and then we have r squared and r, which makes r cubed. So that's where the h goes. That's why that you can use both of these formulas. In textbooks online, you're going to see this formula right here. But also this formula here is easier to use if you're trying to do the math all by yourself. Okay? So if you're given a cylinder, and we all know that I am not an artist here, and let's say the radius from here out is 4 and the height here is 6. So then we would just say that the volume is pi r squared h, and so this would be pi times 4 squared times 6, and so then we would say pi times 4 squared we know is 16 times 6, and then 16 times 6 is 96. So this would be 96 pi. Now that is an exact answer because we know that pi is an irrational number and that we would have to round that. However, if the problem asks you to do that, then you would just say, okay, 3.14, or you could use the pi button in your calculator, which makes you a little more exact if you have that access. So 3.14 times 96. And so then we would do this calculation. And I'm just here multiplying decimals that you know how to do. And I need 2 decimal places there. So we know that that would be 301.44. So this is why on your tests and things, if the answer is 96 pi and you just write 96, it's counted wrong because 96 pi is actually 301.44. 96.4 units, where 96 is nowhere close to that. So that's why this actually says 96 times pi. So therefore, these are equal, but just not 96. All right, so let's talk about a cone then. Let's work an example here. And then, again, you know that my artistry is lacking here. And so then we'll make our altitude here 8. Okay, so we have the volume of a cone is 1/3 pi r squared h. So we just take a third or divide the pi r squared h by 3. Either way that helps you. So we have 1/3 times pi times r squared. Now here we see that all the way across is 12. Well, that's the diameter. I don't need the diameter, I need the radius. So I have to take half of that, which is 6 squared, and then times 8. So then I'm going to say 1/3 pi, and then 6 squared is 36 times 8. Well, if I don't have my calculator, these are large numbers to work with. However, I know if I write this the other way and say pi times 36 times 8 all over 3, because 3 is in the denominator, then I can see that I can reduce 3 into 36. 36 divided by 3 is 12. So really, all I have to say is 8 times 12. And 8 times 12 is 96. And then I have the pi. So again, that's 96 pi. And we already know from the previous example what that is as a decimal. All right, lastly, we have a sphere. Again, we know about my artistry. So let's say that this is 9. Okay. So we would say 2/3 pi r squared h, because the 2/3 is there for the sphere. So 2/3 pi times radius, which is 9, times the height. Well, the height here is all the way across, so this would be 18. Okay, so here I'm going to go ahead and square the 9. So 2 pi, 9 squared is 81 times 18. Again, we can write this all over 3. So here I get a choice. We know that 3 goes into 81 and 3 goes into 18. So we get to choose which one we want to reduce by 3. I'm going to choose 81 since it's such a large number. So 3 goes into 81. 3 goes into 8 2 times with 2 left over. So 2 goes into, that would be 21. So this would be 27. So now I need to say 2 times 27 times 18, because I've already reduced to 3. So then 2 times 27 is 54. So then I have 54. I'll use over here 54 times 18. And so that's 32, 43, and then 4 and 5. And we're going to add here. So this would be 972 pi. And that would be a sufficient answer. Now, what I noticed is that several of you are doing all this work and you're writing 972 on your paper. You cannot forget pi. Again, 972 and 972 times pi are not close to each other. That would be at least 972 times 3 if you try to multiply those together. All right, so from here, everything else is just word problems. Let's talk about some phrases that we need to know. So if I'm giving you a cone and a cylinder and I ask you to find their total volume, this would mean to add. If I ask you to find the difference in their volumes, this would be to subtract. If I say how many times larger is one than the other, that is usually divide. And then we could say, what is the product of their volumes? We know that that means to multiply. So that's simply just from knowing what our words mean in word problems. The thing that I see most is, let's say that in here we get one answer that's 108 pi, and we want to subtract 9 pi. In this instance, when we subtract this does not, the pi's don't cancel. That is one of the misconceptions for some reason we're having. It's like saying 6x minus 4x. That would be 2x. Okay? So when I do this would be 99 pi. I have to include pi in my answer. It's the same for addition and subtraction. Then in division, that is where if you have 108 pi divided by 9 pi, this is where the pi's would reduce to 1. Cancel is not the correct word there. They reduce to 1. So then it would just be 108 divided by 9, which is 12. So that would not be 12 pi. It would just be 12. So this is the time where you don't have to write the pi in the answer because they reduce to 1. However, when you add and when you subtract, the pi does go in the answer. Okay? That seems to hope that clears up some of the confusion that we're having, and have a good evening.